Hey everyone, my name is Veradittakit. I'm a partner at Pantera Capital. We're a large investment firm in this industry managing about $5.5 billion of assets. I'm really excited here to be presenting Joe Petrowski of Polkadot, one of our portfolio companies. He's going to do a presentation, and then afterwards we'll kick it up for a Q&A. Thanks, Joe.
Yeah, thanks, Paul. Yep. Hi, everyone. I realize that I'm up against lunch here, so thanks for joining for this. So yeah, start out with like an introduction to Polkadot. So we started the project back in 2016, and the whole idea was kind of this union of what we call like meaningful interoperability. So there was a lot of different approaches to blockchain scalability, whether it was like packing more transactions into a single chain or having like multiple chains and having messaging between them. And when you have like a message between different chains, so I mean, I think it's kind of obvious like we went the route of having like multiple chains that interact with each other and send messages to each other. But messages are only really like as good as the context that they're in. So like, if you get an email and it says like, we have $50,000 for you from your long lost uncle, you might not trust that so much. So when you receive a message from somebody, you actually have to like trust its veracity and that it's, it's actually true. So like a concrete example of this would be that if a chain sent a message to another chain and the receiving chain actually acted on that message, but the sending chain had been attacked and reorged to a state prior to having sent that message, then you have the situation where the receiving chain has actually acted on some information that is not true. It never actually happened. It's not in the state of the sending chain. So the context has changed. And so you need this idea of security in order to have chains like actually be able to trust the messages that they're receiving. The other main thing was that Polkadot is a meta protocol. So what's actually running in the node software on like a validator client or on a full node is just a WASM executor. So it just executes WebAssembly code and then also runs like kind of the block authorship and finality logic. But the actual Polkadot protocol that like you would interact with as a user, like sending a balance transfer or staking or participating in governance or a Parachain crowd loan, that's all part of a WASM blob that's actually stored on chain. So there's like a special key in the database that actually has all of the Polkadot protocol in it. And so really what people are running is just this WASM executor, and it pulls down the protocol code and executes that. And so the client is really like a protocol that describes a protocol. So any blockchain that can be expressed in WebAssembly can execute on Polkadot, including the Polkadot relay chain itself. And so this also lets us do a lot with governance. So rather than having to like rely on validators to update their clients in order to upgrade the chain, we can encode all of the logic for how Polkadot actually changes into the logic itself. And because it is just like a WebAssembly, a set of instructions under a special key in a database, we can change those instructions under the key. So in Polkadot, on the relay chain, it has to go through this process of having like a public referendum where all the stakeholders can vote on it. But in your Parachain or if you built a chain with Substrate that's using like the same execution model, then you can kind of put in whatever kind of logic you want for like how you actually change the chain. And then you don't need to rely on like any validators or aggregators or anybody to say like what the protocol is. The protocol is just whatever is defined on chain, and the logic for changing the protocol is also defined on chain. So some of the details of kind of like how it's architected. We have this relay chain, which is responsible for the security of the system. This is where like all the validators kind of live, and then providing context for all the parachains. So when you have like parachain messaging, they would send messages to each other, and there's only 20 minutes for this presentation. Could do like an hour-long deep dive into this, but like the state root of like these outgoing messages are included in the relay chain, but the actual messages themselves are just going parachain to parachain, and so the relay chain is providing the context for the execution of these parachains. So basically, kind of like concretely what this means is that you could never roll back or reorg a single parachain. You'd have to move the entire Polkadot network back to this state. So all the parachains kind of advance together. The parachains are responsible for all the functionality in the network. The relay chain is, right now it has some functionality like governance and staking and balances, but our goal is actually to to push all of that into parachains. So we already have a parachain for balances called Statemine on Kusama, Statement on Polkadot, and I have a slide a little bit about that. But the goal is to push everything into parachains, and so the relay chain is actually just like a light client to all the parachains. It has like the block header information, the outgoing message queue, the state route, all the stuff that you would find in like a normal block header. But that's constant size, so it's all just like a bunch of like digests and hashes and like integers and stuff. So the parachain blocks and state can be as big as they need to be, but the information that is going in the relay chain is just the block headers, and it's all constant size. And so this just pushes all the functionality to the edges. All the core functionality of Polkadot goes into the parachains, and the relay chain is just this extremely abstract thing. It just has a bunch of block headers of all the parachains in the network. So this is an analyst conference, and analysts love metrics. So threw a couple slides together. So this is on Kusama, where we have parachains live right now. And just like the allocation of how the tokens are being used in the network. So 42% of them are bonded in staking. 13% are bonded in parachains that are actually active and live. 4% in crowd loans right now. Although there's a current auction that's ending in I think like about 15 hours or so. So some of that yellow slice is going to turn red tomorrow morning. And then 42% is, or sorry, 39% is free right now and like really transferable. But that's like people are actually using this to secure parachains and stake on the network. Other thing is the Treasury. So we have an on-chain Treasury. It's kind of very similar to like a DAO. It's controlled by an on-chain council that's elected by all the stakeholders of the network. On Kusama, we've had 87 approved proposals and given out 72,000 KSM. Likewise on Polkadot, 60 approved proposals and 176,000 DOT. And this goes across like tons of categories. So like we get applications, or say we, like the councils of each network get tons of applications from the community, from building like substrate modules, hosting community events, running public infrastructure like nodes, building tooling. Yeah, it's pretty huge variety. We've gotten like proposals to like write books and other stuff. So it really like spans a quite large gamut of how people are participating in the network. So Statemine was the first featureful parachain that we launched on Kusama. This was back in June or so. So we had this parachain before called Shell. It didn't have any logic in it. It didn't even have balances. There were no transactions that you could make. There was no public API. It just produced new blocks and basically had an interface to listen for a message coming from the relay chain. So it's actually quite neat. We basically said that like the relay chain has like a pseudo type of origin or powers on this parachain called Shell, and it just basically listens for the relay chain to send a message with its like pseudo command to upgrade into another parachain. This is kind of where like that meta protocol thing comes in. So this applies to the parachains, not just the relay chain. Is the same nodes. So we had these nodes that were running Shell, had no logic in it at all, but has this WebAssembly executor. And Statemine didn't actually start at block 0. It was block 300,000 or something that Shell was on, and we just replaced the runtime logic of Shell, which had no public API, into the runtime logic of Statemine, which had all the features for supporting fungible and non-fungible assets, and it just replaced that. The same collator nodes just continued executing this new logic, which is Statemine. And so this is a parachain that specializes in asset creation. And so it has very similar interface to like ERC20 and ERC721 for fungible and non-fungible assets. A really neat thing is that because this is in a parachain and it's being executed in parallel with all the other parachains, you're not using all of the validators to execute it. So like a transaction that goes in the relay chain, every validator has to execute every transaction, just like a normal full node in any other network. But since only a subset is getting applied to each parachain, it's using just significantly less resources in the whole like network. And so we've actually set the fees and deposits. So like if you want to have like a multi-sig account, you need like a small deposit to like instantiate this group of accounts on chain. And it's all set to like 1/10 of the relay chain. So all the fees and everything are 10% of what they would be to use the relay chain. And as we scale the system, we hope to get that down to like 1/50th or 1/100th. we have the first 8 parachains on Kusama, 7 of them via auction. Tomorrow it will be 8, and then 1 common good, which is Statemine. And then we're continually working on monitoring stability. We've seen pretty good performance so far with 8 parachains, and planning to scale that up. And also working on the first cross-chain interactions. So something we're working on with Statemine is adding an interface to be able to send assets to other chains. So in this sense, somebody like Tether could use Statemine as their kind of central point to manage the issuance of their asset on chain. They could send this out to other parachains and use Statemine as their kind of repository of if they want to make queries well, what's the total issuance of my asset in the entire network? They can just look at Statemine and get all that information there. So that's something that we're working on, and we've already seen some of the other teams in the ecosystem make some cross-chain interactions with each other. And now, so that's kind of been the last 6 months to a year, and now some of the stuff coming up in the roadmap. In the midterm, we're working on XCM version 2. So XCM is the cross-consensus message format. And so in V1 and V0, it was kind of you could send off a message somewhere else, and you'd have the guarantee that it would get executed, but you wouldn't really see a lot what happened. So if you sent a message to another chain and said, I want to transfer 100 of these tokens, but you only had 90 in the account, it's obviously going to fail because it's not a valid transaction. But you're just kind of sending this message out, and you don't get any kind of response from the chain. You don't know what were the results of that execution. And so with XCM v2, we've just added some more semantics about the response of the actual chain, how it happened. XCMP, which is the cross-chain messaging protocol. This is the transport layer for XCM messages. Right now, we're using something called XCMP Lite, which basically uses the relay chain as an intermediary to pass these messages. With XCMP, we'll be able to pass messages direct parachain to parachain without any kind of bottlenecks in the relay chain. Another big thing that's been on our radar for a long time and is hopefully coming in the very near future is bridging Kusama and Polkadot together. So we'll probably put this bridge in one of the parachains, and in that case, Kusama and Polkadot would be able to send each other messages over this bridge. And one of the first things that we want to do is actually let the treasuries hold each other's tokens. So in the Kusama treasury, we could actually put DOT into the treasury. And this is actually quite interesting because if you think about other bridged assets in the context of for example, wrapped Bitcoin on Ethereum, you can have an account on Ethereum, own this wrapped Bitcoin, but you don't really have the concept of Ethereum itself owning Bitcoin. And in this sense, you would actually have the Kusama chain itself would hold DOT, not a particular account or anything, but the entire network would have a stake in another network. Other big thing we're working on is contextual execution. So there's another thing could spend half an hour discussing, but right now, just because of the way that parachains get validated, there's some limitations imposed on how much time they can actually process transactions. It's limited to half a second right now, but with contextual execution, we'll be able to bump this up to two full seconds of execution per block, and also be able to execute on every block rather than every other block. So it'll be an 8x speed up in performance. I think just 1 or 2 days ago, Moon River on Kusama, one of the parachains, hit 1 million transactions in 3 weeks. And so with contextual execution, we'll actually have an 8x speed up in capability on that. And of course, what everybody's waiting for is parachains on Polkadot. No, I don't have an actual date for it, but it's coming soon. And then long-term, Spree. This is a shared protected runtime execution environment. This just adds more guarantees about XCMP interpretation and sending. So guarantees around the provenance of a message. So if you send a message to somebody, say I send you a message and I say I burned 100 tokens on my chain, so you can go ahead and mint your claim to 100 tokens. I want to know that you're actually going to mint a claim to 100 and not 500 or something like this, or misrepresent it in your chain. So Spree kind of provides guarantees about how messages get interpreted, and also that the veracity of the information that you're receiving is correct. And finally, nested relay chains, or hierarchical relay chains, sometimes they're referred to, but this would be where the parachains themselves are other relay chains. So we can have, rather than 1 or 200 parachains, if those parachains hold other parachains below them, then we can potentially get to several thousand parachains in the network. And that was it. And I have 5 minutes for questions.
Awesome. Thank you so much, Joe. I have a couple of questions, and then maybe if we have time, we'll open up for the audience questions. You mentioned you have 8 Parachain auctions so far, and 2 of our portfolio companies, Akala and Parallel, have gone through those auctions, and it's a fairly unique way of going about it compared to some of the other blockchains out there. Just kind of curious on, looking back, what was the thinking around the strategy around Parachain auctions, and how do you think it's gone so far? I think for us as investors, it's an interesting sort of exercise, knowing that it's on Kusama, and so we would have to unstake our Kusama and then figure out how much to deploy and what the trade-offs are versus staking it. And but nevertheless, it's been a very engaging process all around.
Yeah, so I've been really surprised not only at the participation in the auctions, but also just the various strategies that we've seen. So we've seen a lot of ecosystem teams kind of offer very similar DOT and KSM
Correct,
structures, but then we've seen some offer completely different. Moonbeam has a completely different allocation of their Moonbeam versus Moonriver issuance. And then we've seen also just huge variations in what people are offering from 1% of their total supply to I think 30% of their total supply. And it's just been completely wild. And another thing was just the overall the quantity of participation. So I was kind of guesstimating that these would be 20 to 40,000 KSM each, and we've actually seen I think the minimum was 118,000, and up to over 400,000 KSM in the auctions. The actual thinking around the auction mechanics was just about getting people to reveal their fair bid as early as possible. So we have this kind of it's called a candle auction, where the end point is retroactively determined by a VRF, and so you don't actually know. The auction is spanning 7 days, but you don't actually know when in that 7 days it's going to end. So you want to put your maximum bid early. And I think we actually have some other ideas about how this crowd loan mechanism could be improved in the future. Specifically, moving it into a parachain so that you're not really constrained by the crowd loan logic that's in the relay chain, but people could write their own custom logic about how they want it to go about managing their bidding strategies. And I think there's going to be the crowd loans now is a bootstrapping thing to get the first ones going, but once we have parachains, I think there's going to be a lot more custom strategies around how people can participate in the auctions.
And I guess one other question I had was around the 8 auctions that have happened so far on the 8 projects. Can you tell us about some of the use cases and maybe the ones that you're most excited about?
Yeah. So we have the first winner was Karura, which is focused on DeFi. And the second one was Moonriver, which is Ethereum compatibility and smart contracts. And then I have to go through there was Kala network, which is focused on privacy and trusted execution environments. It's a long list. Shiden, which is also focused on Ethereum compatibility. One of the things that I think is really interesting is for the last 5 or 6 years, we've thought of smart contracts as a generalized system. So you can kind of program anything on it. And one of the things that Parachains change is that when you have your custom logic that's trusted, so for example, in Statements and Statemine, we have these assets fungible assets, and these functions transfer and stuff. They're not gas metered or anything. They just have a fixed dispatch cost, and they're trusted by the chain. The chain trusts them, and it makes sense because if you think about on Ethereum, the whole purpose of metering, or not even in Ethereum, just the natural language word to meter something is you're trying to measure it. And we've had millions or tens of millions of ERC20 transfers. We know there's not an infinite loop in this contract. We know it's not an attack vector. Why do you have to measure it every single time? That's really wasteful. So you can put this trusted logic into the chain itself. And then that actually turns smart contracts, parachains, not into these general chains, but actually specialized chains. They specialize in allowing untrusted people to deploy untrusted code. And when you have your benchmarked and metered code that your application or your parachain can trust, you can put that directly into your parachain. And then when you want users to be able to deploy untrusted code to your network, then you can use smart contracts, but that gives them a very specific purpose rather than just let's do everything this way.
Thank you very much. We've been looking at a ton of Polkadot projects. I think really it's revolving around a lot of infrastructure, like you mentioned, tooling, moving from Ethereum to Polkadot, privacy networks, DeFi, et cetera. So it's really exciting. Do we have time for one question? What do you guys think? No? Maybe? I'll ask, anybody have a question? All right.
Can you kind of give a little background? I mean, you hear the term Web3 thrown around a lot. Can you kind of explain where the bounds of Web3 are? I mean, generally, I know it's kind of a vague question, but can you kind of go into it a little bit?
That's a good question. I guess like for the mission for the foundation, it's just to enhance privacy preserving technology in a decentralized web. I don't think we have a really formal definition of Web3, and it's still in the making. But yeah, I would say just going back several years to the initial idea that like users would control their own data. Yeah, I wasn't prepared for a question like that.
All right, well, I think that's the end of our time here. Thank you so much, Joe, and learned a lot about Polkadot today.
Yeah, thank you.
All right.